Okay, Assalamualaikum, selamat pagi and good morning. Welcome to the course SIG 2004. This is a second year course at the University of Malaya. This is Sedimentology. My name is Mio Hakif. I will be taking the first part of the course, the first 7 weeks. We will be focusing on the type of sediments and sedimentary rocks that we call silicic clastics. Okay. So this is the first lecture. It's titled Introduction to Sediments and Sedimentary Rocks. For those of you taking this course here at UM, you've already gone through Earth surface processes during first year. And in this introductory lecture, we're going to cover a little bit of some of the topics you've learned before in that course. Just to recap, refresh our memories. Okay, so let's start. So, what is sedimentology? Right? So, the field of study which examines sediments and sedimentary rocks is called sedimentology. And if you want the formal definition, it is the study of processes of formation, transport, and deposition of material which accumulates as sediment and eventually forms sedimentary rocks. So the study of sediments and sedimentary rocks. But what do you study? There are many different subtopics in sedimentology. What is included here is the study of the types and the composition of sediments, and also sedimentary rocks, I should mention. The structures that can form within sediments and sedimentary rocks, how they originate, their significance in terms of deposition environments, the deposition environment itself, its origin is also of interest to sedimentologists. The process of lithification of diagenesis, which is the transformation of sediments to sedimentary rock. This is also a topic of interest. Right? So you have lots of sedimentologists throughout the world. Some of them are specializing in diagenesis, some of them are specializing in modern sediments. Some of them are more interested in ancient sedimentary rocks. So lots of varied subtopics in this. Okay. So going back here, so that's the definition for sediments. Sediments are primarily formed by the accumulation of grains. Okay. So they're made up of lots and lots of particles. So these are three examples of sediments, right? You know them from their common names: mud, lumpur, sand, pasir, gravel, clique. Right? These are things you see on the Earth's surface, right? They're made up of broken up pieces, particles or grains. They accumulate to form deposits, right? And what are they made up of? Well, they are the product of the breakdown of pre-existing minerals and rocks at the surface. So you have older rocks and minerals, and then they undergo the process of weathering, physical and chemical weathering, and they break down into smaller particles that we call grains, right? And these smaller grains will then be transported and then deposited somewhere in the basin, right? By agents of transport like wind, water, and ice. So you get a sediment through these processes. Okay. To better visualize how you produce sediments, so I just show you this cartoon here. This is what is called a source to sink diagram. Okay. So what you have here is a cross-section of the surface of the Earth. On my left-hand side here, you have a mountain range, right? So this is your source. This is older rock. It could be made up of metamorphic rock, igneous rocks, even older sedimentary rock. Or it could be a mixture of all these different types of rocks, right? And then on the other side, on the other end, you have the sink. Another term for the sink is the basin. Basin or sinki. So you have a depression, a topographic depression here, and you have space to be filled in with material. In this case, the material will be in the form of sediments, which accumulate in the basin here. So you go from the source to the sink here. So that's why we call it a source to sink diagram. Okay, so let's go through what happens to a rock as it undergoes weathering, transport, and deposition, right? So we start with the source here. We have older rocks, and the older rocks are exposed to the elements because of uplift, right? So you can have a breakdown in the form of mechanical and chemical weathering, right? And you've learned this already in the surface processes. So you had fresh rock, but these can be broken down into, first, maybe you get boulders here, right? Because of exfoliation, expanding, you get cracks in between, rainwater, right? And chemical weathering, and so on. Okay, so you start to get broken up boulders being formed. And with further weathering and erosion, you can start to get these large boulders being worn down into smaller particles, maybe into cobbles, into pebbles, and maybe later on into small sand grains, right? So all this broken up material, if it stays there, it's just going to be soil. But you have agents of transport. You have rainwater falling down, resulting in rivers runoff, right? And they move down the slope. And as the fluid, in this case water, moves down the slope, it also brings with it these broken up fragments. Okay? So you get sediment being transported. Yeah? So we're now further downhill, and this is what we get, smaller particles, because of the work of erosion and also because of weathering, right? And some of the material can be accumulated in small pockets here, but a lot of it will actually be transported further, in this case, to our endpoint here, our basin here, right? And it accumulates, it becomes deposited, laid down, right? So this deposit is what we call sediment. Okay. Okay, so like I mentioned in the previous slide, you need a medium to transport the sediment from the source to the sink. Okay, so this medium, we call it an agent of transport and deposition. The movement and transport of sediment particles usually requires a fluid medium or agent. Notice here, usually it is a fluid. Doesn't have to be, but most of the time it is a fluid. Okay. What I mean by fluid, remember your secondary school physics, right? It is a substance that continually deforms under an applied shear stress or external force. Okay, so you apply a force, it will change shape, right? So fluids that you know are things like water. Water is a fluid, right? You pour it into a glass, it will take the shape of the glass or a bottle, right? So that's a fluid. Wind is also a fluid, right? But water is more important on our planet. Water is abundant on our planet compared to other planets, right? On Earth, and it is the main agent of transport and deposition. Okay, so you have a large river here, and you have these banks of sand being deposited, and they were brought here by water flowing from the mountains. On other planets, it might be other agents. For example, these are very thick deposits of sand on Mars, and they were transported by winds, transporting fine sand. Okay? So it doesn't have to be in liquid form, it doesn't have to be a fluid. Other agents of transport include ice. Ice is also an agent of transport. Glaciers in cold climates, they move very slowly, but while they move, they also pick up and also break down rock, and they can bring lots of grains, lots of broken up particles from the inland to the sea, and it melts. All this is laid down as sediment in the basin. Okay, so yeah, here we have three typical agents of transport. You have water, air, and also ice. Okay, so we know what sediments are. They're mainly just broken up particles of older rock, which has been transported and then deposited somewhere else in the sink, right? But yeah, Other than that, you also have these things that we call sedimentary rocks. So sediment, so for example here, sediment, it's a sand here, can be transformed into a rock that we call sedimentary rock. Right? And how this transformation occurs is through processes that we lump together into this term that we call lithification. Okay? We've learned about this already also in surface processes, right? Through the process of lithification, which includes things like mechanical compaction, and just put weight from more and more sediment from the top here, resulting in the deposit becoming more and more compact, right? They become closer and closer together, right? The particles. And also with diagenetic processes like cementation, because of water flowing through the pores in between the particles, can result in cement gluing the grains together, right? So you can transform sand to sandstone, for example. Right? So sedimentary rocks are rocks, and a rock is a solid, cohesive aggregate of one or more minerals or mineral materials. Right? And sedimentary rocks formed from sediments. They form at very low temperatures, right? And they form at and near the Earth's surface. Right? So if you apply higher temperatures or higher pressures, you get different kinds of rocks. Right? You get metamorphic rock, or you can even melt it down because of very high temperatures into magma, which cools down back into igneous rocks. But remember, all these different kinds of rocks can be recycled again and turned back into sediment. And the cycle goes on and on. The rock cycle. So we've learned what sediments and sedimentary rocks are, right? We can define them and how they are formed, their origin. But what are they actually made up of? What's inside sedimentary rock, or what's inside sediment, right? So here I list down the main constituents of what you get inside a common sediment or sedimentary rock. First, you can have particles, which are siliciclastic in nature. And this will be the topic of my course, siliciclastic particles. These are grains. I'm just going to use the term particle and grain to interchangeably. Saya akan tukar guna perkataan particle, saya akan guna grain, tapi maksudnya sama. The meaning is the same. Yeah? So siliciclastic particles are particles formed from rock decomposition. They break down the rock, and they are mainly composed of silicate minerals. So minerals like quartz, feldspar, and mica. Or they can be smaller rock fragments made up of more than one mineral. Okay. Other than that, you can also have chemical or biochemical constituents. These are minerals which precipitate out from solution. So let's say you have water, and inside water you have these ions, right? And they are soluble in water. But given the right temperature, given the right pressure, given the right chemical composition, you can start to get crystals forming out of the water. Right? And these are your chemical sediments. Right? Examples of chemical minerals of chemical sediments include bicarbonates, right? Calcite, evaporites such as gypsum, and also apatite. In a lot of cases, biological processes help in the formation of these chemical sediments. For example, you have lots of marine animals with shells, right? Calcareous shells, calcium carbonate, CaCO3, either calcite or aragonite, right? And when the animal dies, the soft tissue is gone. You're just left with the shells, and the shells can accumulate to form a sediment. And this is a biochemical sediment. Then you have carbonaceous material, preserved carbonized residues of plants and animals, which we will learn about later on, in the form of coal, and also in the form of petroleum and so on. Right? And then you also have a minor constituent, what we call autogenic constituent. These are secondary minerals. They also precipitate from from water, right? But they precipitate from the pore waters within the sediment. Right? So you already have a sediment being laid down, you have lots of pores, and you can get these minor minerals growing inside them. And these are what we call orthogenic constituents. And most of the time, these form a very minor part of your sediments and sedimentary rocks. Okay, so we know what sediments and sedimentary rocks are, what they are made up of. So let's now look at the variety of different types of sediments and sedimentary rocks you can have on this planet. Okay? So you need a method of classifying the different types of sediments and sedimentary rock. Also a method to describe the variety of different types of sediments and sedimentary rock. So sediments and sedimentary rocks can be classified based on two criteria. One is the origin, the way that they were formed. Okay? Maybe through chemical precipitation, or was it from physical breakdown? You also need a second criterion, which is composition or particle size. What is the composition of your grains? That's going to be helpful also in classifying the different types of sediments. So using these two criteria, you can generally classify all sediments into two main types. First, you have the siliciclastic sediments, and then you have the chemical sediments. And obviously, from the name, I think you can already understand what the two different groups represent, right? Siliciclastics are mostly dominated by siliciclastic constituents, siliciclastic particles. Chemical sediments are dominated by chemical and biochemical particles. Okay. My part of the course for the next 7 weeks, I'm just going to talk about siliciclastics. The next lecture we'll talk about chemical sediments later on. Okay. So let's just look at siliciclastic sediments and sedimentary rocks. Okay, definition. What are siliciclastic sediments? They are composed of broken up fragments of pre-existing rocks and minerals, and you have particles or grains, right? These are made up of individual fragments, either of individual mineral grains or bits of rock. Zoom into sand, you see it's made up of small particles here. This is quartz, there might be some feldspar in between, right? So it gets just smaller grains. It's made up of rock also. Okay. But in the case of siliciclastic sediments, it is dominated by silicates. So you have quartz being very common in your sands. Other silicates like feldspar and biotite are also common constituents of sediments and sedimentary rocks, but do not include the carbonates, which are chemical sediments. Okay? But you might say, what about bioclastic sediments? Don't some carbonates are made up of grains? Yes, they were formed by breakdown of material of older rock. But remember, we're talking about siliciclastic, so silicate grains, okay? Not carbonates. So you can have clastic carbonates, right? but they're not siliciclastic. It's just a little bit of terminology there. Okay, so we know what sediments are, the definition, the composition, how they were formed, and how to classify them, right? Okay. So let's be a little bit philosophical again. Why? Why are we studying this? Why study sediments, or more specifically, siliciclastic sediments? Yeah? Can you boil an egg with it, and so on? Yeah, I don't know. Of course, it has its uses. If not, we won't be talking about this. Yeah. What I have here is a pie chart. Okay? It's just to show you the relative abundance of different types of rock in the Earth's crust. Right? So notice, if you look at the Earth's crust, most of the material is mainly in the form of igneous rock. A lot of it is igneous rock. Okay, you've gone through igneous petrology, right? Okay. A significant percentage is also made up of metamorphic rock. And we have tectonic deformation, 27.4% on this pie chart here. And sedimentary rocks only make up 7.9% of the Earth's crust. Doesn't even make up to 10%. So just a small percentage of the Earth's crust is made up of what we are studying in this course. So why all the fuss? Well, let's change our view. Look at a different point of view. We are humans, and humans, we mostly interact with the Earth mainly on the surface, right? Not several kilometers underground. Okay. Humans interact with the Earth largely at or near its surface. And if you look at the pie chart for the relative abundance of rocks at the Earth's surface, this is what you get. On the surface, igneous and metamorphic rock only make up about 34%. More than half of the material on the Earth's surface itself, where humans live, is made up of sediments and sedimentary rock. Shale, 35%. Most of it is in the form of fine-grained sediment. Okay? Sandstones and limestone make up the other parts. Okay? So it's going to be important because we are interacting with this material daily. How do we interact with them? You grow food on sediments and sedimentary rocks. You build structures on sediments and sedimentary rocks. KLCC is on top of the Kuala Lumpur limestone. There's limestone at the bottom here. Okay. You take resources out from sedimentary rocks. Petroleum is taken out from sandstone and limestone reservoirs offshore Malaysia. Okay. Groundwater aquifers are mainly sand along the east coast. Okay? So we really need to study sediments and sedimentary rocks because they are very much a part of human life. Humans also hide garbage and other waste material inside sediments, unfortunately. Right? We have our landfills are being filled in with trash. Yeah? A lot of them are associated with sediments and sedimentary rock. And so we hide garbage there. We modify its physical and chemical properties so that it is no longer usable. You get pollution. Lots of these, notice here, you have plastic particles being mixed together with mud in this case. And it seems that plastic particles is becoming more a common component of modern day sediments. Okay, so in order to solve these kinds of problems of pollution, and also in order to manage resources like hydrocarbons and water and food growth, and also in order to construct materials for buildings, we need to understand the properties of sediments and sedimentary cover. We need to have systematic methods to describe these properties, and that is why we are learning about sedimentology in this course. Okay. Now, for practical users, that's fine. Yeah, very important to help us in our daily lives. Sedimentary rocks are also very important if you are interested in Earth's history. I believe some of you are taking geology because you are interested in the history of the Earth itself, and you should know that most of our record of the history of the Earth, going on for several billions of years, is mainly recorded through sedimentary rocks. Okay, events like glacial periods. Mass extinctions like of the dinosaurs, lots of different kinds of fossil fauna. All of these are preserved in the sedimentary rock record. Okay, we know all about these kinds of stories from our studies of sandstone, mudstone, and limestone as well. Okay. Okay. And the way that we interpret the conditions of the past. How do we interpret those kinds of things? Based on characteristics that we see inside sedimentary rocks. You've probably heard this dictum before, right? A present is the key to the past. Right? if you understand modern day depositional processes, you can actually interpret what happened millions of years ago by finding the right clues inside ancient sedimentary rocks. Okay? And from those, we can maybe identify long-term patterns in climate change and use them for predicting what's going to happen in the future. Right? So this is the first part of the lecture. Next part we will go through the language, the terms that we use to describe sediments and sedimentary rocks. Okay, that's it. Bye.